Okay, in this problem, we're trying to find the probability of this event and rounding our answer to the nearest thousandth of a percent. It says a technician is launching fireworks near the end of the show. Of the remaining 11 fireworks, 5 are blue and 6 are red. So we know we have 11 fireworks to choose from, and they're separated into 2 subcategories, 5 blue ones and 6 red ones. If he is going to launch 6 of them in random order, what is the probability that at most 3 of them are blue? So that part right there, at most 3 of them are blue, that's kind of key to this problem. At most 3 means that's the most I can have. So it's okay to have 3 blue. It's also okay to have 2 blue or 1 blue or even no blue if that's possible with the total numbers that we have. So that's what makes this problem a little different maybe than some of the other ones that we look at. And at least problem would be very similar, except you would have to take, like, that would be kind of the bottom number and be from there up with that. But in this problem here, dealing with at most 3, so it means there could be 3, there could be 2, there could be 1, or there could be 0 is what that would mean. So let's take a look at how to handle that on the next screen. Okay, so here's the breakdown of the scenario. We had 11 fireworks, 5 of which are blue, 6 of which are red. We're going to go ahead and list just the ways we can choose 6 things from 2 subcategories of blue and red. I like to always do this. So the scenario could be broken down as 6 blue and 0 red, or 5 blue and 1 red, or 4 blue and 2 red, 3 blue and 3 red, 2 blue and 4 red, 1 blue and 5 red, or 0 blue and 6 red. That's all the different ways I could make 6 out of 2 subgroups of red and blue things. Now, if I take a step back and I look at how many blue and how many red I actually have, I might be able to eliminate some of these cases as even possible. If I only have 5 blue fireworks, I can't possibly choose 6 blue and 0 red because I don't have 6 blue to choose from. So I'm going to go ahead and strike that out as a possibility. Everything else, just based on the number of fireworks I have, still is possible. I can have up to 5 blue. I can go all the way up to 6 red because I have enough. That's fine. Now I need to start looking at the condition. It wants at most 3 to be blue. So that means the most I can have from the blue fireworks is 3. So anything more than that, I would need to go ahead and eliminate. So if the most I can have is 3 blue, I can't have 5 blue and 1 red. I can't have 4 blue and 2 red because the most I'm allowed to have is, in fact, 3 blue. That's what it said in the problem. So this problem is really similar to the exactly problems that we did, only you have to set up a case for each of these scenarios, and then we're going to go ahead and add them together to figure out the total number of ways I can do that and compute that total probability. So I'm going to go ahead and set up 4 fractions here. And the denominator of all 4 of these fractions is going to be exactly the same. We have 11 fireworks altogether, and we are going to choose 6 of them to launch in this problem. So the denominator of all of these will be 11 choose 6. And that's the total way of doing that. Ways of doing that, 11 choose 6 for each one of these. Now, for the numerators, I'm going to set them up just like the numerators in the other problems we did with the exactly problems. And I like the structure of this. It really helps me get it set up. Because I have, let's do this first case right now. I have 5 blue, and I'm going to choose 3 of them. So I have 5 choose 3. And then along with that, I have 6 red, and I have to choose 3 of them. So I have the 6 choose 3. Like, just being able to go down this list the way I've organized this work really helps me figure that out. I go 5, choose 3, 6, choose 3. I've taken care of that case. I have it set up right there. Now I need to do the same thing for the next cases. I'm going to have 5, choose 2 now. So I'll have 5, choose 2. And I have 6, choose 4. For that. Hopefully this is making sense how I'm setting these up. That case is now handled. Set up this case. Again, I have 5. I'm choosing 1, so I have 5 choose 1. And then I have 6, and I'm choosing 5, so I have 6 choose 5 for that. That case is now set up. And then finally, the case where I have 5 choose 0 and 6 choose 6. Like that. I think the hardest part of these problems is actually determining which cases are possible and then getting the cases set up. At this point now, it's just a bunch of plugging stuff into the calculator, computing these, and trying to simplify. So I'll go ahead and do that now. I'll just go ahead and erase the pieces here as I set them up. So I'm going to go ahead and compute 5 choose 3 in my calculator. So I do 5 choose 3, and I'm getting 10. So this part right here becomes 10. 6 choose 3 is 20. On the bottom, 11 choose 6 is 462. I'll go ahead and fill that in for all of these. There's no sense computing that 3 more times. It's still going to be 462 each time for those. Still have some more combinations to compute there, so let me do 5 choose 2, which is 10. 6 choose 4, which is 15. Down here, 5 choose 1 would be 5. And 6 choose 5 would be 6. Over here, 5 choose 0 would actually be 1. There's only one way to choose nothing. And 6 choose 6 would actually also be 1. There's only one way to choose everything for that. So here we have these set up. We can go ahead and do our multiplication now. In the numerators, we have 10 times 20 right there, which would be 200 over 462. Plus over here, 10 times 15 would be 150 over 462. This one right here, 5 times 6 would be 30 over 462. And finally, 1 times 1 would be 1 over 462. When you add the fractions, we have common denominators already, so we're just going to go ahead and add the numerators. 200 plus 150 would be 350, plus 30 should be 380, plus 1 should be 381 over the 462. Don't do anything with the denominators when you have common denominators. And now to go ahead and convert this to our percentage, I'll go ahead and divide 381 divided by 462. I'll multiply by 100 to move my decimal place and round to 3 decimal places. So I do 381 divided by 462 times 100. And then rounding to 3 decimal places, I have about 82.468% for that. So there is an 82.468% chance that at most 3 of the fireworks that I launched would be blue if I was launching 6 fireworks from this scenario. So to kind of summarize, break it down into what the probable, the plausible cases are, and then set up a problem just like we did in the exactly problems for each one of those cases, add them together, then go ahead and divide and multiply by 100 and round to your compute your percentage for that. If you have questions, again, reach out, let me know.